Scientists used to consider Mars a geologically dead planet. It's smaller than Earth and loses internal heat faster. In the past, there was a lot of activity in its depths, and there are many traces of huge volcano eruptions on its surface. The largest volcano in the solar system, Olympus, can be seen from Earth even with an amateur telescope. But volcano eruptions on Mars stopped a long time ago. The planet's interior cooled and solidified. The internal cooling weakened its magnetic field. The solar wind blew away the atmosphere and the remaining water froze. But recently, Mars has become more active. Everything changed when astronomers studied thousands of images of the Martian equatorial region. The images were taken between 2006 and 2020 by the NASA Mars Reconnaissance Orbiter. The HiRISE camera took the images at an altitude of 300 kilometers above the Martian surface. The images allow us to distinguish individual objects with a size of up to 1 meter. The study revealed a large number of landslides and debris flows on the slopes of the Martian volcanoes. Scientists have discovered more than 4,500 traces of rocks that have left characteristic patterns in the shape of a Christmas tree, which usually happens after a strong earthquake. The longest trace is more than 2.4 kilometers long, and in total, these traces are around 900 kilometers long. About a third of the traces weren't present on images before 2006, indicating that they formed later. It's clear that only very powerful underground tremors are capable of moving these huge boulders. However, until recently, such tremors weren't found on Mars. What helped scientists find out that Mars woke up? How did the recent samples taken from one crater almost come to life? And why will one of the most harmful gases on Earth be so crucial for Martian colonists? Since 2018, the InSight spacecraft has been monitoring earthquakes using the Seismic Experiment for Interior Structure. It recorded more than 1,300 tremors, and compared to Earth, this is close to nothing. We have seismometers that record from 500,000 to 1 million earthquakes every year. Besides, almost all the vibrations on Mars are very weak, up to 3 points. The strongest one at 4.2 magnitude was recorded in August 2021. And then in May 2022, the Red Planet experienced a magnitude 5 Marsquake. On Earth, this could knock out windows in houses and slightly damage our infrastructure. But it was quite a significant event for Mars. Earthquakes are stronger due to displacement of tectonic plates and volcanic eruptions. Mars isn't that active, but the 5-point tremors show that tectonic processes haven't subsided in its depths. Movement and magma bursts continue. When magma rises, it causes the bending of a single lithospheric plate of Mars, which leads to Marsquakes. But does geological activity on Mars bring us closer to solving the mystery of its habitability? We know this planet as a very harsh and inhospitable world, extremely cold, with terrible radiation and no liquid water. And of course, there's nothing like elephants, tigers, or even mice on its surface. They wouldn't withstand such conditions, and we could easily notice some of them with telescopes or rovers. But we wouldn't notice microorganisms with these tools. Microorganisms are able to survive in extreme conditions on Earth, so there's a possibility they could also exist on Mars, especially in its depths, where it's warmer and there's no fatal radiation. Additionally, the discovery of subsurface lakes on Mars is an exciting finding, as it suggests the possibility of liquid water, which is an important ingredient for life as we know it. In 2018, radar instruments on the Mars Express spacecraft orbiting Mars detected a large underground lake on the planet's southern pole, as well as 3 smaller bodies of water nearby. The lakes span an area of over 75,000 square kilometers. This region is located in the Plain of Australia, a large ice-covered plain. And in 2022, Instruments on the ExoMars orbiter showed there are also giant reserves of frozen or liquid water in the Valles Marineris canyons. They're hidden inside a canyon system running along the equator of the planet. The water in the canyons covers an area the size of the Netherlands. It's located very close to the surface of the planet, within the top 3 feet of soil. On Earth, similar subglacial lakes in Antarctica have been found to contain microbes, fish, and other organisms. This could also be the case on Mars. A small amount of heat is retained beneath the surface of Mars from the planet's interior, but it may not be enough to melt the ice. This means that lakes may be frozen due to a high concentration of salt. If it's 20 or more times saltier than Earth's oceans, even microorganisms would not survive. In order to understand this, scientists are trying to determine the composition of water in the underground lakes. They're also searching for signs of life in dried-up surface water bodies. Once, many lakes and rivers flowed on Mars. The planet was warmer and had an atmosphere. Many different organisms could have lived in such bodies of water, but up until recently, we couldn't find any traces. In September 2022, the Perseverance rover made a shocking discovery. It found organic molecules near ancient water sources. This wasn't the first time that rovers have found organic matter on the red planet, but this discovery is important because it was made in a place of ancient river-lake merger, particularly favorable for life. It's located in the Jezero crater, 45 kilometers in diameter. The delta formed about 3.5 billion years ago and had been accumulating sand, dirt, and salts over time. Perseverance has extracted the largest amount of Martian organic molecules from this mixture to date. On Earth, fossils of ancient organisms are also commonly found in such sedimentary rocks. The Sherlock instrument on the Mars rover Perseverance, which is designed to identify organic and chemical substances, scanned molecules from the Jezero crater. Among other elements, it detected hydrogen atoms linked to carbon atoms. Carbon is crucial for life and may indicate biological activity. It's also important to note that the organic molecules in the Jezero crater sediment are intertwined with sulfates. On Earth, sulfate deposits preserve organic matter and often contain signs of life. However, the molecules in the crater may have formed through natural processes. Scientists will be able to determine their origin more accurately once samples are brought back to Earth, which NASA plans to do in future missions. Meanwhile, scientists have discovered other hints pointing to the possibility of life on Mars. Recently, the Curiosity rover detected an unusually high level of methane on the planet, 21 parts per billion units of volume. So what does this tell us? Methane in higher concentrations is found in the Earth's atmosphere and is formed due to the emissions of living organisms. Researchers are planning to find out if the gas on Mars is also related to the activity of its inhabitants. If the methane had formed a long time ago, it would have already broken down into its component elements. Another possibility may be that the gas is a product of interaction between rock and water. But methane isn't the only gas scientists are curious about. Carbon dioxide, considered harmful on Earth, may soon become invaluable on the red planet. The experimental device Moxie, the size of a toaster, was brought to Mars on board of Perseverance. Its parts were printed on a 3D printer from a nickel-based heat-resistant alloy. Its composition also includes a lightweight aerogel for heat retention and a thin external gold coating that reflects infrared radiation. Thanks to this, the unique device is able to withstand a temperature of 800 degrees Celsius, at which gas transformation occurs. Moxie has recently produced pure oxygen from CO2. It works by separating oxygen atoms from the CO2 molecules. The byproduct, carbon monoxide, is released into the atmosphere. The tool is designed to produce up to 10 grams of oxygen per hour. However, after an hour of operation during the first test, the gas output was about 5.4 grams, enough to let an astronaut breathe for about 10 minutes. The device is particularly valuable because it's virtually unlimited in terms of raw materials, as the atmosphere of the red planet is 96% carbon dioxide. Also, Moxie uses regolith, which covers the entire Mars. After processing, this soil becomes fuel, air to breathe, or, combined with hydrogen, water. NASA and SpaceX CEO Elon Musk closely follows scientists' discoveries on Mars. The head of SpaceX actively prepares for flights and promises that we'll see the first images of astronauts on Mars in 2029. 14 Raptor engines of the Starship spacecraft have already been tested. Meanwhile, NASA has also chosen Starship as the first crewed landing module for the Moon. If everything goes according to plan, astronauts will land on the lunar surface in 2025 or 2027 as part of the Artemis 3 mission. Then by 2040, NASA plans to send a manned spacecraft to Mars, and the Moon will become a base for refueling. But after the flight, the colonists will still have to settle in extremely difficult conditions on Mars, and that's when new discoveries by scientists will come in handy. Most likely, as experts say, the first crew will land near the planet's equator. The canyon, with liquid water in the Valles Marineris, will be the perfect landing spot. Water is necessary for drinking, growing crops, and sustaining household needs. The settlers will also need oxygen, as the air on Mars is composed of a toxic mixture of carbon dioxide, nitrogen, and argon, and Moxie is getting closer and closer to solving this problem. In addition, Elon Musk plans to refuel rockets directly on Mars for the return trip to Earth. To do this, he wants to build a factory on the red planet to produce methane and liquid oxygen from water ice and atmospheric carbon dioxide. If researchers do find microorganisms in the subglacial lakes, it'll also be a step forward to colonizing the planet. Local microorganisms will be perfectly adapted to the harsh conditions of Mars. By studying them, it'll be easier to find ways to protect against the variety of climatic dangers of the red planet. Mars has fascinated humans for centuries, but it wasn't until the 1960s that the first spacecraft was sent to explore the planet. There have been around 50 Mars missions so far. The first successful mission was Mariner 4, launched by NASA in 1964, which sent back the first close-up images of another planet from space. Since then, orbiters, landers, and rovers have been sent to the red planet by NASA, the European Space Agency, and other international space agencies. Early Mars missions were all about making a safe landing and sending back images to Earth. Today, humanity's aspirations have risen to greater heights, with the ultimate goal of establishing colonies on our celestial neighbor. The presence of water on Mars has long been suspected, and the search for it has been a central focus of multiple space exploration missions. In 2004, Spirit and Opportunity rovers arrived on the red planet. When Opportunity reached a 22-kilometer-wide Endeavour crater, it discovered a mineral vein. After analyzing the vein with the rover's cameras and X-ray spectrometry, researchers confirmed it was formed through the precipitation of gypsum from water that flowed through a fracture in the rock. Spirit and Opportunity have also discovered signs of hydrothermal systems on the red planet. Opportunity's discovery of the Tisdale II rock, enriched in zinc and bromine, points towards past hydrothermal activity on Mars. Such minerals are typically deposited by water, specifically hot water. Meanwhile, the rover's twin, Spirit, discovered 90% pure silica soil in Gusev crater. Martian silica could have resulted from volcanic activity, but scientists also think it could have been produced in hot springs. Hydrothermal systems are known to host various forms of life on Earth, like thermophiles or acidophiles. Life there isn't dependent on sunlight and photosynthesis, but uses chemosynthesis to extract energy from minerals and chemicals found in the water. Evidence of water has been discovered in the most unexpected places on the red planet. Mars has a 5-kilometer-high mountain known as Mount Sharp. It consists of layers with the oldest at its foundation and the youngest closer to the top. Because of this, the mountain stores the information of the planet's Earth-like warmer past and its freezing present. One of the most surprising and recent findings made by NASA's Curiosity rover are rippling rock patterns that point to the existence of water at regions previously thought to be dry. Billions of years ago, the surface waves of a small lake on Mars mixed the material at its bottom, creating rippling textures on the granite over time. Now it's considered the most compelling evidence of water and waves so far detected in the mission. Earlier, Curiosity rover discovered rocks in Gale Crater containing stream-bed gravel indicating sustained flow that occurs as pebbles hit each other multiple times. The stream carried the gravel for at least a few miles, which means atmospheric conditions at Gale Crater once allowed liquid water to flow on the Martian surface. By studying the sizes and shapes of the pebbles in these rocks, scientists calculated water once flowed in the location with a speed about that of a walking pace and was ankle to hip deep. Scientists seem to have collected more than enough data to prove the planet's watery past. But what about its present? Recent research identified a young remnant glacier 6 kilometers long and up to 4 kilometers wide near the planet's equator. Scientists think that ice formed on the top of the glacier and preserved the shape of the ice underneath. Although water ice is not stable at the very surface of Mars near the equator, it's possible that some of the glacier's water ice is still protected at shallow depths under sulfate salts. Unlike higher latitude sites that are colder and more challenging for exploration, this location offers warm conditions for future missions and easier access to possible ice hiding just below the surface. We're used to imagining the red planet as a desert, but it's not the only appearance Mars has to offer. Believe it or not, our close space neighbor has winters too, with snow, ice, and frost covering some of its landscape. Winters on Mars are extremely cold, with temperatures dropping as low as -123 degrees Celsius. Despite its sub-zero temperatures, the amount of snow on Mars is limited to several feet at most, and it falls mainly over flat areas and the planet's poles. This is also where carbon dioxide and water frost blanket Martian surface. So far, scientists haven't been able to observe snowfall on Mars. It's not possible for surface missions to survive the extreme cold, and cameras on orbiting spacecraft cannot see through the clouds. So how do we know it happens? Several scientific instruments make it possible to capture this phenomenon. One of them is NASA's Reconnaissance Orbiter, which detects light in wavelengths invisible to the human eye. And NASA's Phoenix lander, equipped with a special laser instrument, detected water ice snow back in 2008. Martian snow comes in two forms: water ice and carbon dioxide, or dry ice. Because of the way molecules bond when they freeze, scientists think snowflakes on Mars have a weird cube-like shape with smooth edges, while water snowflakes we see on Earth are hexagonal. The Mars Climate Sounder has allowed scientists to determine that the dry ice snowflakes on Mars are extremely tiny, smaller than the width of a human hair. To compare, these frozen crystals of carbon dioxide are about 100 times smaller than terrestrial water snow. Martian winter is about twice as long as here on Earth, and the end of this season is a breathtaking sight. When spring comes around on the red planet, dry ice frost sublimates or turns into gas rather than liquid. This is because of the planet's thin and dry air, as well as cold temperatures. As the first layers of frost sublimate, carbon dioxide builds and heats below the surface before it breaks free. This results in fascinating patterns on the Martian landscape, resembling spiders, polygons, or Dalmatian spots. While Mars shares many similarities with Earth, the possibility of water alone is not enough to create a habitable environment. So scientists are also actively searching for the right chemical conditions that could potentially support life on the red planet. Since NASA's Curiosity rover reached Mars, it's been looking for signs of organic compounds. Studying the Gale crater, the rover drilled into a sedimentary rock. The analysis of the sand and dust left over from drilling demonstrated abundance of such vital chemicals for life as hydrogen, oxygen, sulfur, nitrogen, carbon, and phosphorus. The Curiosity rover has also found an ancient river system. The soil at this region contained clay minerals, sulfate minerals, and chemicals with different levels of oxidation, meaning a possible energy source for microorganisms. Several rock samples found in Jezero crater by the Perseverance rover have also shown organic matter. Researchers think that about 3.5 billion years ago, the 45-kilometer crater used to be a river delta. The rover has found both sedimentary and igneous or magmatic rocks using its Sherlock instrument, which stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. The results showed sulfates, carbonates, and unexpected salts. In fact, the rover discovered carbon-based matter in every rock it analyzed, and even though organic matter can be produced in non-biological processes, it's exciting these molecules were found in sedimentary rock, which we know is capable of preserving fossils of ancient forms of life on our planet. The possibility that Mars may have once had a habitable environment suggests that this barren planet may have had more in common with Earth than we previously believed. One day, NASA, in cooperation with ESA, plans on returning all the samples collected by the rovers back to Earth. Perseverance has already gathered 18 samples, and when they're brought back to laboratories, these bits of Mars debris and cores from rocks will be a source of scientific inquiry for decades. About 60 years ago, and for the first time, humans saw what Mars really looks like. Today, we have an extremely detailed and interactive mosaic of the planet's surface, made up of around 110,000 images. A 5.7 trillion pixel mosaic was made by NASA's Mars Reconnaissance Orbiter's context camera, and even though it took 6 years and tens of thousands of hours to develop, we now have the best global picture of the red planet ever produced. The journey of Mars exploration has been a fascinating one, but it's not over yet. It seems we're on the verge of an extraordinary discovery, indisputable evidence of past life on the red planet. As we uncover more about Mars and its potential for supporting life, the prospect of transforming this barren world into a habitable planet grows ever more promising. On February 9, 2022, NASA's Parker Solar Probe took its first real images of Venus in visible and near-infrared light. The probe used its wide-field imager to capture the entire night side of Venus. NASA combined the images the Parker Solar Probe took as it flew past the planet and compiled a video. Here's what the Parker Probe captured. The footage shows a faint glow on the planet's surface, the outlines of its continental regions, plains and plateaus, and even an incredible glowing halo of oxygen in the atmosphere. Scientists assumed the Parker Solar Probe would only capture the tops of the clouds that hide Venus, but it exceeded their expectations and was able to see the planet's surface through the dense veil of its atmosphere. According to scientists, due to the planet's incredibly high temperature, the rocky surface of Venus glows like a piece of iron pulled from a forge. Long before that, the USSR dreamed of landing their probes on Venus, but they had several unsuccessful attempts. Venera 4 and Venera 5 were the first USSR spacecraft that managed to transmit valuable information about the planet's atmosphere. They discovered that dense clouds in as many as 3 layers enveloped Venus. And in December 1970, the Venera 7 became the first probe to soft land on the surface of another planet. Thanks to a powerful cooling system, it lasted 23 minutes under intense heat. With the help of measuring instruments, the probe transmitted detailed data on the temperature, pressure, and atmospheric density back to Earth. Meanwhile, NASA started launching missions to Venus. The first American spacecraft to fly by and study Venus in 1962 was the Mariner 2 space probe. The data received turned all ideas about the Earth's twin upside down. The probe showed a desolate, red-hot world with temperatures reaching 900 degrees Fahrenheit. The thick atmosphere of Venus was found to consist of corrosive sulfuric acid and carbon dioxide, and the atmospheric pressure 9 times greater than Earth's, enough to flatten any ship. The first close-up image of the planet was sent by the Mariner 10 probe in 1974. the image was edited to show what Venus would look like in color as seen by human eyes. It shows thick clouds of carbon dioxide that envelop the red-hot planet. And the Venera 9 and Venera 10 probes took their first images directly from the planet's surface, landing a few days apart in October 1975. To prevent the cameras from going out of service immediately, they were placed inside the ship in a protected compartment. Through a special porthole, light from the surface reached the periscopic device, which then directed it to the camera. The images lacked detail and appeared in black and white because the color cameras could not withstand the high temperatures and pressures of the planet. But for the first time, people could see the surface of a world located 61 million kilometers away from Earth at its nearest. The image made by Venera 9 shows a terrain covered with numerous rocks with sharp edges, and the Venera 10 panorama showed some bizarre formations resembling something like frozen lava flows. The Venera 14 spacecraft, launched from Earth in 1981, also took great images. It stayed on the planet's surface for 57 minutes. The instruments were stored in a sealed titanium case and cooled down considerably before they reached the surface. The camera module managed to take 14 colorful and 8 black and white images of the planet's surface. This stunning colorful panoramic view became particularly famous. It captures rock formations surrounded by dark, shallow soil. Several incomprehensible objects can also be seen in this desolate landscape. A team of scientists from the Space Research Institute of the Russian Academy of Sciences has published an article suggesting they are signs of civilization on Venus. Some of the details in the image resemble a disk, a black cloth, and a scorpion. These objects suddenly appear in the frame, move, and then disappear. But the sensation didn't last long. Soon it turned out that the images included parts of the probe that had fallen off after a difficult landing. These were the last images of Venus taken by the Soviet probes, but the photo shoots of the planet were just beginning. In 1989, the US launched the Magellan spacecraft, which brought us many vivid images of Venus. They show the ancient volcanoes of the planet, unique meteorite impact craters, and incredibly huge mountains. The tallest of them, Maxwell Montes, is 11 kilometers high. To compare, Mount Everest is just 8.8 kilometers high. The dark crater to the right and above the center is called Cleopatra, and the black stripes in the image are unmapped places. Among the areas of Venus shown by the Magellan, there's something breathtaking. Located in the Estler region of Venus, this is a volcanic edifice 66 kilometers across the base. There are also some incomprehensible lines across the terrain. These are tesserae, tectonically complex units that occupy about 8% of the surface of Venus, commonly occurring as high-standing crustal plateaus that are embayed by lava flows from the adjacent volcanic plains. So far, such patterns have only been found on the surface of Venus. And here's another unique area of the planet with a diameter of about 300 kilometers. A large circular structure near the center of the image is the giant Ain Corona, a volcanic formation about 200 kilometers in diameter. Coronas are unique ring-shaped structures on Venus. They were formed by plumes of red-hot rock flowing from deep within the planet through the mantle and crust. Not far from the corona, there's something else, a so-called pancake dome, approximately 35 kilometers in diameter. Unusual in appearance, these pancake domes are generally a few tens of kilometers in diameter, approximately 1 kilometer high, and are remarkably circular in shape. Scientists say they were formed by ancient eruptions of an extremely viscous lava. The planet first seemed to be devoid of internal energy, but it turned out to be quite active. Tectonic activity may still continue in the depths of Venus, and volcanoes could still spew lava on its surface. This is the volcano Mat Mons. Although it's not an actual direct image, The Magellan spacecraft couldn't see the surface of Venus through the thick layer of clouds, but its onboard radar surveyed the planet and transmitted the results to Earth. Here, a computer generated stunning views of Venus based on the received data. Mat Mons is the tallest volcano on Venus, 8 kilometers high, and scientists suspect a recent eruption. You can see a huge crater in its center, and a chain of very small craters scattered around the area. The images are incredible, but what about this talk of possible life living in the clouds of Venus? Astronomers have long speculated that Venus's clouds might be home to microbes. Unlike the incredibly high heat on the planet's surface, the temperature in the Venusian high clouds reaches a comfortable 30 degrees Celsius, although these clouds also contain about 90% sulfuric acid. Scientists at the Massachusetts Institute of Technology are now looking for supermicrobes in the planet's clouds. But NASA is planning on launching 2 more probes, the Da Vinci and Veritas missions, to try and uncover more about Venus, and the European Space Agency will send the Envision orbiter to the planet. Russia is also preparing a project called Venera D. Roscosmos plans to send an orbiter and a lander to Venus, and it's hoped that the lander will be able to withstand the harsh environment for an entire month. The orbiter and lander are expected to transmit many images of Venus to Earth in visible and near-infrared light. Decades of extensive studies have demonstrated just how remarkably intricate Jupiter is. Just recently, 12 more moons orbiting the gas giant have been discovered. The total number of satellites around Jupiter is now 92, more than any other planet in the solar system. The latest moons discovered have sizes ranging from 1 to 3.2 kilometers. A majority of these moons have extensive orbits, with 9 out of 12 taking over 550 days to complete one revolution around the planet. Scientists believe that because these distant moons move in the opposite direction of Jupiter's rotation, they could be captured asteroids. It's been widely believed that Jupiter acts as a protective shield, safeguarding our planet from threats from outer space. In the past, astronomers have even suggested that this was one of the reasons life got a chance at evolving on Earth. But recent findings cast doubt on Jupiter's role as Earth's celestial guardian. Long-period comets, which originate from the distant regions of the solar system and take millennia to orbit the Sun, typically enter our vicinity. However, thanks to Jupiter's gravitational influence, most of these swiftly moving icy objects are flung away from the solar system before approaching Earth. So the chances of long-period comets colliding with our planet are extremely rare, occurring over millions or even tens of millions of years, and Jupiter's presence plays a crucial role in shielding Earth from these potential impacts. However, the gas giant's gravitational forces have both positive and negative implications for life on Earth. On one hand, its immense gravity prevents nearby space rocks from accumulating and forming into a planet. This led to the formation of the asteroid belt, a collection of numerous small debris fragments scattered between Mars and Jupiter. But nowadays, the gas giant's gravitational pull continues to influence asteroids, causing some to deviate towards the Sun. This change in their trajectory increases the odds of collisions with Earth, and we've already witnessed it in the past. In 1770, Lexell's comet passed just about 1 million miles away from our planet, an extraordinary proximity on an astronomical scale. Scientists believe that this comet had initially come from the outer reaches of the solar system and had a close encounter with Jupiter that redirected its path towards Earth. After completing 2 orbits around the Sun, the comet returned to a point of close proximity to Jupiter 9 years later, which subsequently ejected it from our solar system. The Jupiter shield theory, supported by previous computer simulations, suggested that the gas giant ejects countless long-period comets out of the solar system. And this theory even predicted the comet Shoemaker-Levy 9 striking the 5th planet in 1994. But computing resources weren't as powerful as they are nowadays, and scientists had to make a lot of calculations. Today, we have data that includes a greater number of short-period comets and near-Earth asteroids that intersect with Earth's orbit
compared to long-period comets, and new simulations demonstrate a different picture. Jupiter's influential gravity interacts with the asteroid belt, causing gravitational resonances that clear out rogue asteroids and redirect them inward. Collisions between asteroids can also contribute to this process by dispersing rocky fragments into resonant zones. The inner edge of the asteroid belt is particularly affected by a phenomenon known as secular resonance, which drives material into the inner solar system. Jupiter's current mass allows it to both redirect comets towards Earth, as seen with Lexell's comet, and effectively remove them from the solar system. If Jupiter had only 1/5 of its current mass, it would still destabilize comets, but lose the ability to remove many of them, leading to a higher impact rate on Earth. The frequency of impacts plays a crucial role in the long-term evolution of life on a planet. Earth's geological record indicates that an impact rate of one major collision every 100 million years provides enough time for the biosphere to recover and thrive. However, a higher impact rate, occurring every few million years, could devastate the planet, hindering the development of a new biosphere. Some scientists believe collisions with Earth is also how water was brought here. But what about water on Jupiter? Water vapor was first detected on Jupiter in 1995. This discovery was made by the Galileo spacecraft, which conducted extensive observations and measurements of the planet and its moons. The onboard instruments of the Galileo spacecraft, particularly the near-infrared mapping spectrometer, detected the presence of water vapor in the planet's atmosphere during its close flyby. But recent data demonstrates water makes up approximately 0.25% of Jupiter's atmosphere above the planet's equator. While this may not sound like a lot, it's actually an immense amount of water. Jupiter, probably the first planet to form in our solar system, contains a significant amount of gas and dust that didn't become part of the Sun. Knowing just how much water is locked up in Jupiter is crucial for scientists studying the formation of the solar system. In recent years, a team of researchers used telescope data to discover a substantial presence of water within Jupiter's famous Great Red Spot. Launched by NASA in 2012, the Juno spacecraft currently orbits the gas giant, taking close-up pictures of its clouds. Equipped with advanced instruments, the spacecraft has now revealed even more evidence of water on Jupiter. Because this massive gas giant holds more than double the combined mass of all the other planets in our solar system, even small fractions of water on such a massive planet would amount to a significant quantity, far exceeding the amount of water found on Earth. Water in the gas giant's atmosphere is also the reason why Jupiter, just like Earth, has its own mesmerizing displays of lightning 100 times brighter than terrestrial lightning and peculiar hailstones. Lightning has been detected in the planet's water clouds in the past, where water droplets collide with electrically charged ice crystals. But the Juno spacecraft has also spotted dim lightning at higher altitudes in the atmosphere, where the temperatures drop to approximately -87 degrees Celsius, too frigid for water to exist in its liquid state. So how does lightning happen under such conditions? The answer to the mystery lies in ammonia, a remarkable component in Jupiter's atmosphere that serves as a natural antifreeze. In the upper atmosphere, water ice crystals combine with ammonia vapors and melt. These water ammonia droplets then collide with additional ice crystals from below, creating an electrical charge that generates lightning. Below the ammonia ice clouds, the ammonia water droplets undergo continuous growth until they become too heavy to remain suspended in the air and resemble large hailstones like we have on Earth. Scientists believe that these mushball-like objects descend deeper into Jupiter's atmosphere. But now, let's travel even deeper into Jupiter's innermost layers. Previously, it was believed that our solar system's giant worlds all have a rocky core. This was the accepted theory for a very long time, but recently, scientists have started to doubt this theory. Using Juno's orbit data, scientists are still studying how matter is distributed inside Jupiter, and recent discoveries have unveiled an unexpected mystery lurking within the gas giant's core. Jupiter's core has extremely high pressures, much greater than on Earth. and temperatures as hot as 20,000 degrees Celsius. To understand these conditions, scientists use powerful lasers to compress samples and mimic the planet's pressures in a laboratory. The Center for Matter of Atomic Pressures at the University of Rochester is at the forefront of this research. The density of materials in Jupiter's core depends on their composition and physical properties. And just recently, scientists have discovered that Jupiter's core is not as compact as they thought it was. Deep within its inner regions, only 18% of the material is rocky. Jupiter is predominantly made up of hydrogen, accounting for about 90% of its composition, along with roughly 10% helium and trace amounts of other elements. In the outer layers of this gas giant, hydrogen exists as a colorless and transparent gas, in the same form as it exists here on our planet. As you descend deeper into Jupiter, the increasing atmospheric pressure transforms hydrogen into a bizarre, dense fluid that conducts like a metal. So what is this substance? Approximately 10% of the way towards Jupiter's core, along its radius, the immense volume of hydrogen gas that forms the planet's atmosphere becomes compressed into a unique form known as liquid metal hydrogen. Liquid metallic hydrogen possesses properties similar to water, with low viscosity, excellent electrical conductivity, and efficient thermal conduction. Within Jupiter, this abundant substance transforms the planet into one huge generator. On Earth, elements exist as solids, liquids, or gases, depending on temperature and pressure. While hydrogen is typically a gas on our planet, it can be compressed and cooled artificially to become a liquid or solid. However, even in these states, hydrogen retains its non-metallic nature, poorly conducting heat and electricity. In contrast, metals excel at conducting heat and electricity due to their atom arrangement. Deep within the gas giant of our solar system, hydrogen undergoes extreme temperature and pressure, which allows for peculiar states including liquid metallic hydrogen. Hydrogen atoms under these conditions shed their electrons, resulting in a mix of free-floating hydrogen nuclei and electrons. This electron mobility resembles metal behavior. There's a theory that Jupiter's core might be filled with vast oceans of this substance, and based on previous estimations of the Jovian core's mass, it could be 12 to 45 times more massive than our planet. A 40,000 kilometer deep layer of liquid metallic hydrogen, combined with Jupiter's rapid rotation of about 10 hours, generates a colossal magnetic field that spans an astonishing distance of 725 million kilometers. This magnetic field stands as the largest in our solar system, and it contains mysteries of its own. Exploring regions more than 320 kilometers down into Jupiter's atmosphere, scientists have identified a newfound area known as the Great Blue Spot, not to be confused with Jupiter's Great Red Eye Storm. Researchers knew that the Jovian magnetic field was complex, but they had no idea just how weird it was. And it has something to do with the Great Blue Spot. The Jovian magnetic field is 20,000 times stronger than the Earth's magnetic field. But now, scientists have discovered that its strength is volatile. Unlike the Earth's dipolar magnetic field, the gas giant's magnetic field originates from a wide area in the northern hemisphere and re-enters near the South Pole. Researchers have also identified a concentrated region just south of the equator, the Great Blue Spot. Is like a second Jovian South Pole located near the equator. The colossal storm that's raged for centuries is probably caused by the presence of high concentrations of ammonia in the atmosphere. The intensity of the magnetic fields in the Great Blue Spot undergoes fluctuations of up to 1% per year, strengthening and weakening across different regions. By the end of the extended Juno mission in 2025, scientists will have ample evidence to evaluate their hypothesis. As research continues, we're going to encounter new mysteries about the gas giant. Since the Great Blue Spot and the Great Red Spot are located at the same latitude, it's possible the two phenomena are somehow connected. Gas giants are typically characterized by their high temperatures, especially in their upper atmospheres. In our solar system, there are two such giants, Saturn, and Jupiter. However, Jupiter doesn't have a consistently high temperature throughout its entire structure. The solar system's largest planet is mostly known for its massive storm, twice the size of Earth, the Great Red Spot, but the gas giant has other spots too. The Great Cold Spot is nearly as large, and scientists have been observing this phenomenon for years now. At its largest, the spot is approximately 12,000 by 24,000 kilometers across. But unlike the famous red spot, this intriguing atmospheric feature stands out as a region of significantly colder temperatures compared to its surroundings, about 200 degrees cooler than the surrounding atmosphere. The Great Cold Spot is volatile, disappearing and reappearing from time to time. Scientists have discovered that this phenomenon's recurrence is triggered by the planet's auroras. Because of this correlation, the spot's age is about the same as the age of Jupiter's polar lights, which is in thousands of years. Jupiter's auroras, similar to Earth's, are produced by charged particles interacting with the planet's atmosphere near the poles. However, the gas giant's polar lights are more stable and intense, as they receive particles from both its moons and the Sun. New findings indicate that these auroras transfer energy to Jupiter's atmosphere, creating a temperature difference between the upper and lower regions. This temperature contrast leads to the formation of a swirling vortex, resulting in a cooler patch that is distinct from the aurora and its surroundings. Earth also experiences similar effects. However, the combination of factors like Jupiter's rotation that helps retain heat in specific areas and the varying nature of these events makes the occurrence of polar lights on our planet less consistent. Another discovery made about the gas giant was that, contrary to common belief, Jupiter doesn't actually orbit the Sun. The center of gravity between Jupiter and the Sun does not reside within the Sun itself, but instead exists at a specific point just above the Sun's surface. In space, where a smaller object seemingly orbits a larger one, both objects actually orbit around a combined center of gravity. Consider Earth and the Sun, for instance. In this case, the center of gravity is so close to the center of the larger object that its impact is hardly noticeable. The larger object appears motionless, while the smaller object traces a seemingly perfect circular path around it. The same happens when the International Space Station orbits the Earth. Both the Earth and the ISS orbit around their shared center of gravity, even though our planet seems to be completely stationary, while the ISS appears to orbit the Earth in perfect circles. This principle generally holds true for most planets in our solar system. Even Saturn has negligible influence on the Sun's position in space. However, as the difference in mass between the two objects decreases, everything changes. In the case of Jupiter, its immense size causes the center of mass, known as the barycenter, to exist 1.07 solar radii away from the Sun's center, approximately 7% of a solar radius above the Sun's surface. This means that both the Sun and Jupiter orbit around this particular point in space.
October the 15th, 1997. Cassini was launched into space by NASA, a high-tech object the size of a school bus and worth $3 billion. In order to accelerate such a device, it was necessary to use the gravitational field of 3 planets. It passed next to Venus twice, in 1998 and 1999. Then, at a speed of 69,000 kilometers per hour, it rushed near the Earth, and only a year later, in 2000, it picked up the required speed, passing by Jupiter. It was not so easy to accelerate the device weighing 5,710 kilograms, but with each new month, it became easier. After all, more than half of Cassini's weight was fuel, the reserves of which were decreasing every day. Having flown 3.5 billion kilometers, Cassini approached the rings of Saturn. In photographs, they appear smooth and gaseous, but in reality, these are billions of space debris pieces ranging in size from a fingernail to a huge building. And given the speed at which the Cassini was moving, a collision with even the smallest fragment was enough for the entire apparatus to be instantly destroyed. But luckily, Cassini made it through the rings safely, and it sent unique footage to Earth, which helped make several amazing discoveries. For example, scientists used to think that each one of the rings of Saturn is the same, but Cassini's pictures showed that all the rings are different. even those that are close to each other. In addition, scientists were able to find out that the thicker the rings, the older they are. Thanks to gravitational measurements during the maneuvers, Cassini found that the approximate weight of Saturn's rings is 15 quadrillion 400 trillion tons. Most likely, Saturn's gravity is tearing apart icy moons and comets. From their debris, the rings are formed. But in 2004, Cassini photographed something else that especially interested scientists. In one of the outer rings of Saturn, they documented the presence of small moons. Scientists have taken pictures of the particles they're composed of, collecting and scattering nearby small satellites. In other words, Cassini managed to photograph the moment of the formation of a smaller system within a system. This is an absolutely grandiose find. According to scientists, thanks to the observation of these processes, it's possible to obtain information about the formation of our solar system. In the end, we'll be able to find out how planets are formed in protoplanetary disks. And one more shocking discovery. Saturn devours its own rings. From the rings to the surface of Saturn, there is a real shower of water droplets and dust. And shower is saying too little. This is a real cosmic hurricane, because every second, Saturn devours up to 45 tons of ring matter. During its mission, Cassini documented the dynamics of the change of rings. Rings D and C are going to disappear. But by human standards, Saturn will not devour its rings soon, for this will take at least 700,000 years. But the main goal of Cassini, of course, is not the rings, but Saturn itself and its satellites. And the resulting photos of the planet did not disappoint. Cassini managed to record an incredible storm at the planet's north pole. Its diameter is 32,000 kilometers and its speed is 150 meters per second. It's scary to even imagine how it looks from inside. And what is phenomenally different about it, this storm has a perfect hexagonal shape. This storm is 50 times the size of a hurricane on Earth, and even the walls of this vortex go deep into the atmosphere at up to 100 kilometers. Research into the origin of this storm is still ongoing. In total, Saturn has 82 known satellites with a confirmed orbit, each of which is somehow different. For example, Hyperion is a natural satellite, looking like a 360-kilometer potato. The pictures showed that it was all composed of rocks and ice. Hyperion looks like it survived a terrible bombardment, but the porous surface is not explained by this, but by the extremely low density of the planet. Because of this, only 60% of the planet is composed of ice, rock, and metal impurities, and the rest of its internal volume is made up of cavities, which we also see in Cassini's photographs. Another satellite of Saturn, Tethys, raises a lot more questions. Cassini took color photographs which clearly show unidentified red stripes on the surface of the satellite. Their origin is a mystery. They look as if someone drew them. One of the versions is the huge cracks that formed on the satellite, as if something is splitting taffia from the inside. But what is it? Hot lava or unique chemical components? So far, it's not been possible to find out. As if something is splitting Tethys from the inside. But the most interesting is the most important satellite of Saturn, Titan. To investigate Titan, a specially designed Huygens probe was placed in Cassini. On December the 25th, 2004, Cassini launched Huygens into the hazy atmosphere of Titan. The probe entered the atmospheric layers of the satellite. Due to the terrible friction, Huygens' heat shield warmed up to 1,500 degrees, but the probe survived and landed safely. Before Cassini's trip, no one could even imagine what surface the probe would land on. But all signs of landing indicated that Titan's surface is a hard surface, beneath which is a soft and light substance. Further discoveries were truly amazing. It turned out that Titan is the best factory known to man for the production of organic compounds. Almost the entire satellite is covered with a layer of frozen hydrocarbons that resemble gasoline. In other words, if humanity dug a mine on Titan, then we'd be able to provide the entire Earth with oil for thousands of years. But that's not all. The most important discovery was ahead. Judging by all the data obtained by Huygens, Titan's atmosphere is predominantly nitrogen, just like the atmosphere of our planet. That, together with complex carbon compounds in Titan's foggy atmosphere, allows to suggest that Titan is a suitable place for the existence of life. One minus: it's too cold on it. That, however, does not interfere with the existence of deep lakes, thousands of years old. True, if on Earth reservoirs are filled with fresh or salt water, then on Titan they consist of methane and ethane, with a temperature of about minus 180 degrees Celsius. You'll hardly want to swim in there on vacation with your family. Huygens' expedition made it clear that Titan is the most Earth-like object in the solar system known to us. There's also lakes here, seas, flowing rivers, rainfalls. There's even a change of seasons here. True, each of them lasts for 7 Earth years. The potential for exploring this planet is very high, and in the future, if humanity does begin to colonize, Titan will most likely be used as a galactic station for the extraction of resources. However, the discoveries on Titan are not the most astounding ones that Cassini made. By pure coincidence, scientists came across other information. Saturn's other moon appears to have life. It's about Enceladus. It's covered in ice, but it shines like a lamp. Its surface reflects more light than any other body in the solar system. When Cassini approached the satellite, it made interesting shots against the background of the sun. They showed that Enceladus has its own geysers that eject water vapor and ice into space. The temperature at the South Pole turned out to be much warmer than originally expected. Enceladus was not so icy. The temperature in the south was enough to melt the ice and turn it into water. Scientists cannot give an unambiguous answer to the nature of the origin of this heat. At the moment, there are 2 assumptions. Either radioactive elements are hidden inside of Enceladus, or heating occurs due to the powerful gravity of Saturn. But this is not the most important thing. Another thing is important. Enceladus has water, heat, and organic molecules. And these 3 components are necessary conditions for the birth of life. Perhaps living organisms unknown to mankind are hiding just a few meters under the ice on Enceladus. They feed on dissolved organic compounds and reproduce by some kind of DNA analog unfamiliar to humans. Unfortunately, Cassini's cameras cannot see through the ice. Therefore, this mystery remains unsolved. Other expeditions will have to find out if there's life on Enceladus. In any case, this satellite is currently the most promising place for the search for extraterrestrial life in the solar system. Cassini's mission could not last forever. Since its launch in 1997, the probe has existed for 20 years. The last phase of its life was called the Grand Finale. It was a suicide mission for science. The Cassini probe made 22 flights between Saturn and its inner ring, sending priceless images back to Earth. And then it headed straight for the gas giant, broadcasting everything live. And it burned up in the atmosphere of the planet, fulfilling its duty to science until the last second. Thanks to the Cassini mission, we got incredible facts about Saturn and its moons. And perhaps we came close to the discovery of the first living form of life in our solar system. A new space project, Titan-Saturn System mission, is already being prepared. The exact launch date of the project has not yet been disclosed, but it's known that it will definitely happen before 2029. After launch, the new space project will follow the path of Cassini, and after 9 years, it will approach Saturn. This time, the mission will not be limited to photographs alone. Among the plans of scientists, there's even a task to send samples of Saturn's moons back to Earth. Perhaps this new mission will provide answers to the questions that we got thanks to Cassini. There's 4 gas giants out there in our solar system, but unlike Jupiter and Saturn, Uranus and Neptune are rich in water. Most of that water is in the form of ice. And now new studies found there may also be oceans under their icy layers. But that's not all. Researchers now say these oceans could be rich in magnesium. But these oceans might be made of something else entirely, and we'll get to that soon. We need to mention that even though Uranus and Neptune are considered gas planets, they're also called ice giants because of their rocky, icy cores, which are much larger than the amount of gas they hold. But some strange things have been discovered lately, and researchers have been trying to figure out what is happening on the surface of these 2 ice giants. Not only that, but some have wondered what it might be like if you tried to land on any so-called surface of Neptune and Uranus. You may have also heard that it could actually rain diamonds on these planets. And now some researchers believe that both Uranus and Neptune could have oceans of liquid diamonds. Now that sounds wild. But how is this possible? Keep that in mind, because we're going to get to that in a couple of minutes. But first, let's take a look at each of these planets, and we'll tell you the most incredible things that have been discovered up to now. You have to admit that Uranus is a bit of a sad and lonely world, one that's tired of being the butt of many bad jokes, including that one. However, its name is actually a reference to the Greek god of the sky. This freezing world was the first planet ever discovered using a telescope in 1781 by William Herschel, and is about 2.9 billion kilometers from the Sun. Voyager 2 got as close as 80,000 kilometers from the planet and captured only a handful of images. But those images had astronomers thinking it's possible that something really big crashed into Uranus in the early days of the solar system, not once, but twice. The result of these two big impacts left the planet rotating on its side. This means it's orbiting the Sun like a rolling ball, which, by the way, takes 84 Earth years to go around once. Uranus has 27 moons, and they could have formed from these big collisions that put the planet on its side. Also, its magnetic north and south are way different from its polar north and south. Because of this, there are some really bizarre seasonal effects. Imagine a planet that has its south pole pointing at the Sun, while the north pole is shrouded in complete darkness for 21 years. In 2011, telescopes showed something strange happening on the planet. A big fuzzy white spot appeared on its frigid blue cloud tops, and astronomers claimed it was a giant methane storm. In fact, some of these storms have been spotted by the Hubble telescope. Huge storms, half or more the size of the entire USA. The average temperature in the methane and ammonia clouds is minus 128 degrees Celsius. Winds on the planet can reach up to 144 kilometers per hour. And by the way, Saturn isn't the only planet in the solar system to have rings around it. Uranus has two sets of rings, both orbiting above its equator. But its icy twin Neptune is even farther away from the Sun, some 4.5 billion kilometers away, and it takes 165 years to orbit the Sun. Voyager 2 was able to get as close as 4,828 kilometers to Neptune, which appears to be made up mostly of ices and rock, and could possibly have a rock-ice core about 1.2 times the size of the Earth, and around 10 times the Earth's mass. Its atmosphere is made up of 3/4 hydrogen and 1/4 helium, with a small amount of methane that produces clouds. The bluish color of the planet is from light scattering and red wavelength absorption by the methane in its atmosphere. Like Jupiter's giant iconic red eye, Neptune also has a huge dark vortex, an anticyclonic storm called the Great Dark Spot that's 11,000 kilometers across, almost as big as the Earth, and it's racing across Neptune at 1,100 kilometers per hour. But that's not all. In fact, Neptune has the most ferocious and fastest planetary winds in the entire solar system, reaching 2,000 kilometers per hour. Definitely no place for a holiday. The energy for those high-speed winds is not coming from the Sun, but what might actually be happening closer to the core of the planet. In fact, Neptune appears to have some kind of internal heat source and radiates twice as much energy as it gets from the Sun. And even though it's farther away from the Sun than Uranus, it's a bit warmer, thanks to Neptune's atmosphere, which is probably holding in heat from its hot core. Now, both of these planets have unstable and strange magnetic fields that are strongly tilted relative to each planet's rotation axis, and are significantly offset from the physical center of each planet. It's been a long mystery for some time now, and no one's sure why these magnetic fields act so strange. The magnetic field on Neptune is 27 times more powerful than that of the Earth, while Uranus only has a magnetic field 1/3 as strong as the Earth, and we'll explain in a minute what scientists think is causing the magnetic fields to act strange. Even though it might seem really cold on both of these worlds, and the magnetic fields are bizarre, intense heat and pressure thousands of kilometers below the surface of each planet may tell a different story. The atmospheres of both planets are primarily made up of hydrogen and helium, with small amounts of methane. Below these atmospheric layers is a super hot, super dense fluid of icy materials like water, methane, and ammonia that wrap around the planet's core. Because of this, astronomers studying these two ice giants have come to the conclusion that it could be raining diamonds closer to the surface of each planet. This is possible because deep inside both these ice giants, pressure and heat builds until gaseous hydrogen turns into liquid metallic hydrogen. Methane in the atmosphere decomposes, and as the bonds holding methane's 4 hydrogen atoms dissolve, the carbon atoms left over bind to one another under extreme pressure to form diamonds. At its core, Neptune reaches temperatures of up to 7,273 Kelvin, which is comparable to the Sun, while the core of Uranus heats up to 9,000 degrees Fahrenheit. Yes, it could actually be raining diamonds closer to each planet's core. But not only that, it's also possible that there are oceans of liquid diamonds beneath the surface of the 2 ice giants. Research was done by taking detailed measurements of the melting point of diamond. When diamond is melted, it behaves like water during freezing and melting, with solid forms floating atop liquid forms. Obviously, diamond is a very hard material, making it really hard to melt. And measuring the melting point of a diamond is also very difficult, because when it's heated to very high temperatures, diamond changes to graphite. But it's diamond that turns into a liquid, not graphite. So what scientists did to get around this problem is expose the diamond to extremely high pressures by blasting it with lasers. Diamond is liquefied at pressures 40 million times greater than found at Earth's sea level. When the pressure is lowered to 11 million times greater than the Earth's sea level, chunks of diamond start to appear. But something happened that scientists didn't expect. The chunks of diamond didn't sink, but floated on top of the liquid diamond layer, creating diamond icebergs. These are the same ultra-high temperatures and ultra-high pressures found on both Uranus and Neptune. Both planets are estimated to be made up of 10% carbon, so a large ocean of liquid diamond could deflect or tilt the magnetic field out of alignment with the rotation of the planet, which could explain the strange magnetic field behavior. Is it possible that both planets rain diamonds and have vast oceans of liquid diamond? Only by sending a spacecraft there will we find out. Now researchers and scientists are trying to get NASA to send a spacecraft to these 2 worlds in order to study them. But the planets will be closest to the Earth soon, and astronomers say that a spacecraft would need to be launched by 2030 in order to take advantage of Jupiter's gravity and slingshot the spacecraft towards these ice giants to arrive in the mid-2040s. In April 2021, astronomers spotted X-rays coming from Uranus using the Chandra X-ray Observatory. This revealed some unknown dimension of the colorful ice planet. This means that X-ray emissions have been detected on every planet in our solar system now, except for Neptune. In case you're wondering, there are 3 ways a planet can produce X-rays: fluorescence, scattering of solar X-rays, and emissions from auroras. Uranus is scattering the sun's X-rays, and X-rays are also being created by energetic electrons or protons, which collide with the rings, causing them to glow in X-rays. It's pretty much the same thing that causes Earth's beautiful and amazing auroras. We may soon know a lot more about these 2 mysterious planets in the future, so make sure to stay tuned here to stay up to date. Thanks for watching.